Hi, good morning everyone. Today I like to make one video. In this video I like to explain to how to make a DOL starter. DOL starter is using to start an electrical motor, whether it is three-phase motor or single-phase motor. In this example, we like to explain to make how to design a DOL starter, designing and manufacture a DOL starter for 5.5 kilowatt three-phase starter. For before starting up the designing process, we should know the current flowing through the motor or current ampere of current handled to our starter, or find out the full load current of the motor. In this case, we are assuming that our motor is 5.5 kilowatt. So how we can find out the full load current? Full load current when motor is in the full load, what will be the current flowing through the motor? That is called full load current. So finding out that full load current, we are using one equation. I will show that equation in the notepad. This is the equation. In this first line, we write 5.5 kilowatt three-phase motor. 5.5 kilowatt three-phase motor. In this 5.5 kilowatt three-phase motor, how we can find out the full load current? So here is one equation: kilowatt into 1000. This 1000 is using to converting the kilowatt into watts, because for getting the current in ampere or in ISI standard, all the unit of measurement should be in ISI form. So the unit of ISI form of the power unit is in watt. So we have to convert the 5.5 kilowatt into watt. That is 5.5 kilowatt into 1000. So kilowatt into 1000. Kilowatt is equal to VI root 3 cos phi. This is the major equation. VI root 3 cos phi. This root 3 or 1.73. This is the value of root 3, 1.73, which is coming in the picture because this is a three-phase starter, three-phase motor. If it is a single-phase motor, only this equation will consider VI cos phi. Cos phi is nothing but the power factor. This power factor is we are considering normally as 0.8 for the motor starter calculations. 0.8 is the 80% of the power factor. What is the power factor and all? This maybe we will take another tutorial class for the power factor. Now we will just consider 0.8 as the power factor. So our equation: kilowatt of the motor is equal to voltage into current. Voltage across the motor winding and the current flowing through the motor. And if it is a three-phase motor, actually three winding is there, but we are not multiplying by 3, but we are multiplying by 1.73 into cos phi. Cos phi is the power factor. Okay. Power factor is coming from the 0.8 we will consider. We are not getting 100% or not unity. Power factor will not get the unity as 1. So it is 0.8 we will consider. Then the next step, the equation is 5.5 into 1000 is equal to 400 into I we don't know, actually we are going to be find out that I, and the 0.8 into 1.73. The next step, I is equal to 5500 divided by 4 into 0.8 into 1.73. This is the normal equations solving method. So I think everybody know about this. So I is equal to 5500 divided by 553.60, and I is equal to 5500 divided by 5. This is by mistake I write once again. So the final I we will get 9.93 ampere. So the full load current of 5.5 kilowatt motor is equal to the 9.93 ampere. Now we know the current should be handled by our starter, which is 9.93. So when we are going to be design the starter or manufacturing the starter, we should mainly consider this one, and also consider the voltage. Well, the voltage only we are getting this current. So because we are going to be manufacture or design the starter by using different type of the electrical components. So these electrical components have its own voltage parameter, its voltage um, its own technical parameter like ampere, voltage, and all these things. So this before using that component, we should know the full load current so that that component can be selected according this ampere rating parameters of that electrical parameter of that components. May first it is coming. I will show some major components which is using to the designing a starter, which is mainly uh, the major component is 1 minute. This is the one of the major component which is using to the starter. This is nothing but a uh, contactor. Contactor is this is one of the contactor. I will show little bit big this contactor. This is contactor. This is contactor from Schneider Electrical. I am normally using the Schneider Electrical components. I have the library for this Schneider Electrical. So and I have experience in that products. So I have just showing that devices. Some other company like ABB and other company also you can refer, but the functions will be same and look also may be same. This is the contactor which is using to switch the mainstream current to the electrical motor from the power supply to the motor, and this can be controlled by the small auxiliary supply, and that auxiliary supply we can use for the control purpose, and we can using different switch, or we can send through the float switch, and all that is the normal current. And actually this contactor have a one electrical coil inside this. That coil is operating under 230 volt, not the three phase volt, but different voltage levels are available in the market. In this case I am saying about 230 volt. I am considering the 230 volt coil supply contactor, and 440 volt is also available. 24 volt AC and DC also available. You can select according to your requirement, and the part number will be vary according to the operating voltage and the current also. We have different current range contactor is also available from 9 ampere to maybe up to 500 630 ampere. We are selecting according to, because when the current handling capacity, current capacity is high, contactor size will be increased and the price also increase. So we have to select the proper ampere rate of the contactor for proper designing of the starter. In our case, it is 5.5 kilowatt three-phase motor, and the full load current, the current flowing through the starter is 9.93 ampere. So we have to, this is 9.93 ampere. Actually, this contactor beginning with the 9 ampere, 12 ampere, 18 ampere, 25 ampere, 32 ampere, 40 ampere, 50 ampere, 63 ampere, like that it is going according to the ampere rating. The part number also change. So in our case it is 9.93 ampere. This ampere rating is higher than 9 ampere. So we will consider as a 12 ampere contactor. So the contactor we have to consider for the this 5.5 kilowatt motor or DOL starter. You have to consider the contactor is equal to 12 ampere. We cannot consider 9 ampere contactor because our full load current is more than 9 ampere. Anyway, after getting the calculated current a little bit, if the range should be little higher than the calculated current the motor, so it will be safe. Otherwise, maybe after a long use of this contactor may be contact point of the contactor maybe get burned or something, and easily it will damage. So we will consider 12 ampere contactor, and basically this Schneider contactor which I shown in the picture is AC3 duty. That means it can be handle the electrical motor. Means electrical motor have the special electrical characteristic like that. Like when motor is going to be start in the starting phase, it will take maybe 5 to 6 times current of the full load current. So, but this contactor is manufacturing to handle that starting phase current, that is AC3 duty. So we don't worry about that. This is called motor. This contactor is designed for the starting up of the motor. This is LC1D series contactor type, LC1D in the Schneider catalog. So this is AC3 duty contactor. So our contactor we selected as a 12 ampere contactor. So we have to consider one 12 ampere contactor with the coil voltage, which is when this coil voltage is giving to, actually this power supply is giving to this this contactor have L1, L2, L3 points of here, and in here also down also we have three big electrical point. The power supply should be connected to that. All things I will explaining in while I am explaining the drawing. So this we consider the contactor with the contactor 230 ampere with the 230 volt operating system, 330 volt coil voltage, VOL voltage. So whenever we give 230 volt to the coil supply of this contacts of this contactor will be closed, and the main power is connected to the motor, and motor will be start to run. And when this coil supply of the contactor is disconnected, and this motor will be stopped. So, and this coil supply is very small amount of current, very small. I mean, no need to full load current should flow through this coil supply. So this coil supply we can take the control wherever you want, like a float switch in the overhead tank, or in the down tank, or somewhere like that. We can use this coil supply to control the rotation of the motor. So this is the main use of the starter we are using, because if you keep one manual switch, we cannot make any control over that one I will little more explaining in the while I am explaining the sorry sorry drawing section. So the other thing is we have to consider for the DOL starter is the MCB main MCB, which is using to the protection of this motor wire, everything. So I will show one more picture of the MCB here. Sorry. This is the MCB. This is also three-phase MCB. To have three poles here, three pole. We can give the three-phase supply, incoming three-phase supply to this device, and from the output of this device it will go to the other part of the circuit, and we can switch off and on this device, so that our DOL starter will be isolated, or it will be connected to the circuit. So here also we have to consider the ampere rating of this MCB. MCB is also coming from various range from 6 ampere to very big range. So we have to select according to our requirement. In our requirement is for 5.5 kilowatt starter, we need only 9 ampere. So, but there is one thing, whenever the electrical starter is in the starting phase, it will take 5 to 6 times more current. But that thing also we have got this MCBs, are this normal MCB for using for the designing of starter is not motor protected range. That is very price is very high. So for that type of MCB, motor protected MCB. So normal MCB we are using. So if we are using normal MCBs, we have to consider the starting current of the motor. It is 5 to 6 times starting current of the motor. But this MCB also have some curve characteristic when it is tripping. So after now in this case we have to actually our current is 9.96 ampere, but motor will take around 6 times more current during the starting phase. If we take the current is 9.96, if we consider 10 ampere 6 times, or means it is 60 ampere, we have to use the MCB. But the MCB also have some curve characteristic like C curve, D curve and all. In this curve characteristic it will take little more time. As soon as the current over limit the current limit of this MCB will immediately not trip, but it will take a little millisecond. That is called in the curve of graph will come. That millisecond it will take, and during that millisecond itself, our starting phase of the motor will become down some particular level, maybe 60 ampere in during the starting, and immediately within millisecond it will reach to maybe 25 ampere. By considering both this motor starting phase current curve and the MCB current curve, we can compromise the starting phase of the motor current as a 2.5 or 2 to 2.5 times of the full load current. So that means we don't need to use full 6 times higher MCB. Suppose full load current is motor current is 10 ampere, no need to consider the 6 times 10 into 6 60 ampere. We have to just consider 2.5 times extra for the MCB for the DOL starter, 2 to 2.5 times. 2 is also okay. So this will be depending upon the curve characteristic, but roughly we are taking 2 to 2.5 times. So our current is 9.96 ampere, 2 times if is 18 ampere. So in this case we can consider 25 ampere MCB. By this explanation, I think you understand the things. So the MCB is equal to 25 ampere. 25 ampere TPMCB. TPMCB. Okay, so contactor we selected and MCB we selected. This is the major components, and other components is called overload. This is one of the major component of the starter, overload, which is using to the protect the motor from the overload. Whenever the motor is struck or something, it is jam or it is taking more current, which is more load, which is actually designed for this motor, then the current will also increase. So this current if increase and run some particular time, maybe half an hour, 15 minutes, 20, depending upon the current. Normally for the motor starter we are using thermal overload. I didn't have the picture of the overload. I will search in the Google and I will show you. Yes, any side overload. This is the overload. This overload also have a three phase of overload, and this overload directly we can connect to the contactor. So this current will be coming to the top side of the contactor and flowing through this overload, and then from the bottom side it is going to the motor. So this contactor is this overload is basically a thermal overload. So it can be coming with some range of setting. Suppose in our case we need our motor circuit having 9.96 ampere, so we can consider some 8 to 12 ampere overload. It is coming with different range like 1.2 to 2.24, 2.426 like that. So there is one part number is also there, LRD 4.6 like that. I will check one. I will show you one part number of the overload LRD 1.1 to 1.6 LRD 06. Actually, we need around 9 to 12 ampere overload, and if you select 9 to 12 ampere overload, that one have some particular part number like LRD 12 or something. So if you consider, if you take 12 ampere, 9 to 12 ampere, and by this by use of this knob, we can set the current according to our value. 10 ampere or 12 ampere we can keep it, 10 ampere we can keep it. If you set this overload up to 10 ampere, then if the motor is taking more current, then our motor should be take 9.93 current, but in some case due to overflow or some bearing jam, or motor may be taking more current, like more than 10 ampere or 12 ampere for a certain time, then in the thermal overload will be trip. So like this way like this overload will be give a thermal protection for the motor, thermal protection for the motor, over current protection to the motor and all. And this MCB will give a short circuit protection and everything. So our charge starter is now considered with the contactor, MCB, and overload. And there is one more overload we have to consider, 9 to 12 ampere. 9 to overload is equal to 9 to 12 ampere. We can, if we are, as I am selecting Cider from the Cider catalog, we can get the overload part number LRD012 or something. Exactly, we know we have to use 9 to 12 ampere, and we can set it in between. And other important thing is called ELCB. This is for the earth leakage protection. This is one picture of the ELCB. This is called 4-pole ELCB. Neutral is also going through the ELCB. So neutral plus 3 phase, then total 4-pole ELCB we are using. ELCB ampere rating is we have to consider, we have to take the ampere more than the our full load current. Our full load current is 9.96 ampere, but ELCB normally coming with 25 ampere, 40 ampere, 60 ampere. ELCB is only this ampere rating of ELCB just we have to consider, because our ELCB should be capable to handle that much current. So if our motor is 10 ampere, we can take any higher ELCB, no problem, but not less than 10 ampere. But ELCB normally coming with the 25 ampere, 40 ampere, 63 ampere. So in this case, but the main electrical parameter of the LCB is the milliampere setting. So that milliampere is the specification of the LCB. That means the LCB will trip if some more than that particular milliampere is flowing through this LCB, the fault current. So normally LCB is coming with the 30 milliampere, 100 milliampere, and 300 milliampere. So for normal motor application, we have to consider 100 milliampere LCB, because 30 milliampere is very less. As this motor is handling with water and all, there may be chance to little bit electrical leakage. If it is 100 milliampere, it is safe. It will not trip very frequently. So for this purpose, ELCB is in using. So in our case, we will use the ELCB. ELCB is equal to 40 ampere, 100 milliampere, 40 ampere, 100 milliampere, 4-pole ELCB. As we have 4-pole ELCB. So these are all the different electrical component which is using for designing a 5.5 kilowatt DOL starter. So now all the component we are selected. Now we will explain the drawing. In this drawing, this is the circuit diagram of the electrical starter. In this, we can directly give this 400 volt AC 3-phase supply, 50 hertz with the neutral. 3-phase we can directly give to the MCB, bottom side of the MCB, and from the MCB we will take the 3-phase to the, this is actually shown isolator. This isolator I didn't consider in the material. For small motor it is not there. From directly from the MCB we can switch on and off. So isolator we can avoid. This is for the bigger panel. Like if our electrical starter have two or more starters, then we have to commonly use one isolator. So in this case, it is not necessary. So directly we can give to the MCB. This is the MCB, and our case we told we need a 25 ampere MCB. Our MCB is required 25 ampere GP MCB, 25 ampere, 25 ampere GP MCB, and it will go for the ELCB, 4-pole ELCB, and this neutral line, this is bottom line is neutral. Neutral is also coming to the ELCB. So whenever the earth voltage more than, this is 100 milliampere is 40 by 100 for poly LCB, more than 100 milliampere fault will detect by this LCB, it will trip and no more current will flow through the remaining circuit. So it will be protect the earth leakage. And then it is coming to the contactor, three-phase contactor, three-pole contactor. Each phase is connected to the one side of the contactor. From the other side of the contactor, it is going to the overload, and overload is maybe 9 to 12 ampere according to the particular manufacturer catalog. We can select that range. Maybe this is not exactly 9 to 12 ampere or something, and the part number is also LRD 12 or something, and we have to select it. From the overload, it is going to the terminal. Terminal is nothing but electrical terminals, which is having the electrical connectors inside the PVC insulator. So electrical connector, which this wire will be connected in that. From that, you can take it to our motor, 5.5 kilowatt motor, three-phase motor. 5.5 kilowatt motor have a three DOL starter. This is DOL starter. So three wire will be go from this panel, and it's three connect to U1, V1, W1. Maybe select that point will be available in the motor U1, V1, W1. You can connect there U1, V1, and W1. Okay, this is the power circuit, and control circuit will be like one small MCB. We can use like a control circuit for this is one single pole MCB, maybe 6 ampere MCB we can take it out, and this 6 ampere MCB, from the 6 ampere MCB we are taking the supply, control supply, and the neutral also directly we are taking for the control supply. When this 230 volts is taking, and this is the selector switch. Selector switch have two different pole. So when the switch is putting in one side, that we call the auto side and hand side. When we put it in auto side, that supply will come through this side. When you put it in hand side, supply will come to the other side. In the middle section is called off. I have one picture of selector switch. This is the selector switch. So this is two side is here, one side is here. So auto off hand switch. So, and this is the overload. Our overload have one more auxiliary contact, like overload like this. Here, this 1, 2, 3, 4 screws are there at the top side. At the bottom, the main power is going to be motor from this this way to this bottom screws, three. So the top side of small screws are using to connect the control circuit. Here this NO is normally open contact, and this NC is normally closed contact. It will be normally closed, but whenever it is stripped, it will be open. So this NC contact we will use in this drawing. This NC contact use in the drawing to connect the coil. This is the coil of the contactor. When this coil is getting 230 volt, this contactor will get closed. This contactor will get closed. This contactor will get closed, and supply will flow through this overload, and motor will start run. So this is NC contact. Whenever this overload is tripped due to over current or overheat, this contactor will be open, and this coil supply will be disconnected, and motor will be stopped. In that way, motor will be protected from overcurrent and over temperature. And the NO contact of the same overload, NO contact, normally open contact, and this will be closed when the overload is detected trip. So it will be closed. And this contact is directly connected to the 230 volt and to an indication lamp. So this indication lamp will be glow when the overload is trip, and operator can understand motor is in trip status. And when this coil is connected, one more indication, I will show one indicator picture. This is the indication lamp. There is different color of lamp is available: green indication lamp or a yellow indication lamp. Yellow indication lamp is basically using for showing the trip indication. This Y symbol is here yellow, and this green is called green indication lamp. When green is showing motor is in run state, it is directly connected to across the coil of the contactor. This is the trip contactor, no contactor at all. So it will be trip. So this when put in auto side also it will directly run, hand side auto it will be done. If we want connect some circuit like float switch or something, we can use some. I will show you like this. We can use some some terminal like terminal like this terminal. This is terminals. We can provide one set of terminal by cutting this line, and people can connect float switch here. Float switch. Float switch. So if you connect a float switch in between this terminal, and if we keep the auto off and switch in auto mode, current will try. If it is in auto mode, current will try to flow through this side. So in this side we are connected a float switch. This float switch can be put it in a overhead tank, so that whenever the water level in the tank is get high, this float switch will be go up and it will be disconnect this circuit, and then if, this supply to the coil of the contactor will be disconnected and motor will be stopped. Same way, whenever the water is going to be down by the use of the people, water is going to down in that overhead tank, the float will go down, and again it will be close this circuit, and this coil will get energized and motor will run. Like this we can automatically control the motor to fill the water tank in overhead water tank. Same way we can maybe use one more float in the well or underground tank from where the motor is taking the water, that can be used for the dry run protection. Or if there is no water in the tank, pump will be get damaged, water pump will get damaged if still motor is running. So we can protect that one also by providing one more float switch in common area of the switch, like for both auto and hand operation. This hand operation is directly on switch on and of the motor right now. So this is the explanation of the designing of DOL starter, and during the next tutorial class I will like to make more video with more complicated circuit with starter and with other control components. So I hope this video is helpful for you. If you have any doubt regarding this video or DOL starter, you can contact me through the comment area. I will help you. And if you like this video, please share this video to your friends and other colleagues so that they can also helpful for this. Especially, I want to show this video to some students or who is studying this electrical starter or something. So this is my video regarding the DOL starter. Thank you very much for the watching.